Hello boys and girls, as I mentioned in class, we will continue to complete page 40, but I'm only going to address number 10 and the hot questions at the bottom. Okay, as we see right there. Okay, I have the hot questions. We'll work on number 10, but for 8, 9, and 11, I want to go over them in class. Okay, I will be checking for completion, that you have made an effort to complete those. These are relatively easier than number 10, as I was looking at. But the only thing that's a little bit difficult about number 10 is the fact that they're asking us for an equation. Okay, and they're asking us for the equation for area. Don't forget that area has two dimensions: length times width. So we always have to consider both of them, because sometimes you might have 6 by 10. So you have to consider both lengths to make sure that you get the area correctly. Anyways, let's zoom in and work on number 10. Okay, Kevin's Flooring sells different sizes of square floor tiles. So different sizes. Some might be a foot long, some might be half a foot, others might be a whole 2 feet, 2 by 2 feet. So they're all different size, and this is Kevin's Flooring is the name of the store. Carl, the person that wants to buy them, wants to purchase 10 tiles. So he wants to purchase 10. 10 is our constant. Okay, that one has been determined for us already. Write an equation that can be used to find the area of any 10 square floor tiles. Hint, area equals side by side, length times width. Don't forget that. Area is 2 dimensions. So we're looking for area. Whenever you're being asked to look for something, go ahead. I'm going to do it right down here. Okay? So you go ahead and you write A, because we know we're looking for area. Well, that's what we're being told. We're saying write an equation to find the area. Find the area. So we're looking for the area. So what does area equal? Well, area is going to equal the number of tiles, right? And then whatever the length, the size of the tiles are. If it has the length of, let's say, 6 units, 6 inches, it's going to be 6 by 6. So I know that I have to have the 10, right? Because it's 10 tiles. But we're trying to look for the dimensions. How long and how wide is it going to be? If it's 6 inches each, okay, we have to multiply that times 6 and then again times 6. Because if it's a perfectly square tile, as they've mentioned up here, square floor tiles, it's going to be 6 wide and 6 long. But for the sake of writing an equation, we will not write 6, we will write S for sides. So now it's going to be area equals 10 tiles times the side times the side. Now I kept the same variable S because it doesn't matter, they're both the same, okay? So area equals 10 times S times S times size times side. Okay, let's make a table. Make a table to find the area covered by 10 tiles that measure 6 inches, 12 inches, 15 inches, and 24 inches. So we simply have to replace these with these lengths so that we can find the area in inches for 10 tiles at these sizes. So we could simply say 10 times length times width. Okay? 10 times length times width. And that'll give us our area. For question B, we're being asked to make a table. So make a table to find the area covered by 10 tiles that measure 6 inches, 12 inches, 15 inches, and 24 inches. We're going to look for that area, okay? So essentially all we need is to line up the sizes and find the areas. The sizes will be our domain, and the areas, the ranging areas, will be our range. In the middle, we've included another column which is the formula for the area, which is our 10 tiles times the sides. Okay, if it's the side is 6, as we have here, it will be 10 times 6 times 6. So our first size is 6. We have the side 6. To solve for the area, we'll multiply it by 10, which is our constant. Okay, 10 tiles, and the length is 6 and the width is 6. So we multiply 10 times 6 is 60. 60 times 6 is 360. And then we have our first area. That's our area for 10 tiles with sides of 6 inches. Let's do the 12 inches. Okay, now we have the sides for 12, and we have our 10 tiles times length times width equals 1,440. The way I did this was I multiplied 12 times 12, and I got 144, and then I multiplied that times 10 to add the 0. And that's how I was able to multiply that a little bit faster. Okay, then we go with 15. Okay, following the pattern, sides are 15. Here we multiply the 10 times 15 times 15. Well, 15 times 15 is 225. Times 10, you add the 0, and there you have your new area. And the last one, 24. Okay, same as before. So 24 equals 10 times 24 times 24, which is 5,760 again. 24 times 24 is 576 times 10, you add the 0. And there we have, now we have our domain and our range. This was just to show how we went from domain to range. And now we're being asked to graph. Okay, so we must graph it. I'll show you how it's graphed in the textbook, and you will have to graph it on your own. Okay, so for any graph, the first thing you need is always the title, and then you need your y-axis, which is your range, and your domain, your x-axis. Okay, as we explained, along the bottom, we have the sides in inches, right? And you can see that we're jumping by, we're varying by 5 inches each time. Okay, and then our range is in thousands. I've left the first answer or the last answer there for you so that you can see where our S value, our sides, okay, our domain is 24, so we go along down to 24. Here's 25, so just before it, 24. And our area is 5,760, so we go all the way up past 5,000, over the half between 5,000 and 6,000, and we stop around there. And you can see that that's our point. I want you guys to go ahead and plot all the other ones, the 6, the 12, the 15 as well, okay? They'll be around here. Okay, as I promised, I would be helping you with the hot problems, the higher order thinking questions. Let's look at number 12. Okay, I'll see if I can zoom in a little bit more. Tickets to an amusement park are $26 each. Write an equation to find the total cost, so our variable for cost will be C, for tickets. Okay, graph 4 order pairs to the relation. Now, this is very similar to what we did in class, boys and girls. In class, we talked about Y being our range. Okay, it could be the prices, the weight, anything. And then we need to have our constant, and constant, I'm going to replace it with the C, which is the number. Here we're given a constant of $26 each for the amusement park, times the number of tickets, right? That will give us our domain and our range, right there. But here we're being asked to use different variables. We're going to use C, and we're going to use T for tickets. Now, that's not too much that we have to change, so we can just say that we want to find the final cost, okay, for the number of tickets, which we know is $26, and it'll be tickets, okay, tickets, number of tickets right there. That would be our equation. So go ahead and copy that one down for that answer, okay? And let's start using some key answers. Here we'll start with just a simple star. Okay, number 13. Number 3. Okay, write a real-world situation that can be represented by the equation y equals 4x. So 4 is our constant, x is our domain, and y is our range. So something that is being multiplied by 4, okay, a value that's being multiplied by 4 that will give you a total value. What could be this situation? So here's one idea. My idea here is $4 could be the cost of CDs. Okay, so each CD would cost $4, and let's say you replace your X with 3, so you bought 3 CDs at the price of 4, would give you 12. So there you have your domain and again your range. Another idea could be $4 represents a slice of pizza. So you could buy, let's say, 4 slices of pizza. That would replace the X with 4, so you have Y equals 16. Okay, so think of a real world situation on your own and write it out. I'm looking forward to seeing that answer. Number 14. Write a rule for the relation shown in the table. Here we have a relation. We have the domain and our range, and we have 1 becomes 10, 2 becomes 12, 3 is 14, and 4 is 16. Now we have to look for a pattern. Clearly it is not it's constant rate, but it's not a proportional relationship because it starts at 10 and then it goes up by 2 each time. Okay, so there's no actual unit rate. But let's see. If I multiply 1 times 2, I get 2 plus 8 is 10. If I do the same thing here, multiply 2 times 2 is 4, plus 8 is 12. 3 times 2 is 6, plus 8 is 14. Yep, that's our rule. So write a rule. Go ahead and write. If you just figured it out, go ahead and write it. If not, pause the video and try to see if you see a pattern right there, a rule, okay? And then check my answer. Pause now. Okay, so what I was explaining was that y, the way we can get y is by multiplying our x into 2, we double it, and then we add 8. Okay? Go ahead and copy that down and draw a little flower next to it to show me that you watched this part. But please check. Go ahead and check. You see, if we multiply 2 times 1, we get 2, plus 8 is 10. If we do 2 times 2 is 4, plus 8 is 12. 2 times 3 is 6, plus 8 is 14. And 2 times 4 is 8, plus 8 is 16. Okay, so yeah, this equation works. Number 15. Let's see. Give an example of a situation in which it is best to represent a relation by a table. Give an example of a situation in which it is best to represent a relation by an equation. Okay, and justify your choice. Now, explain your choices, really. Okay, let's do a table first. When talking about the weather, okay, if you want to show the daily temperatures, a table would be appropriate. You can show, for example, in the X, you can show the days, okay, the days of the week, or even the months of the year, and then in the Y you can show how the temperature ranges, okay? So a table would be appropriate to show the different temperatures. Okay, what about for an equation? Let's stick to the idea of the weather, okay? To show how the temperature is changing at a constant rate, an equation would be appropriate. Remember how we just did an equation for y equals 2 times x plus 8? Okay, an equation like this explains how, okay, a constant rate is changing, okay, or how it's changing at a constant rate, because it's always going to be constant, not necessarily proportional, but definitely constant. Okay, go ahead and let's make this one final key answer, as we have right there for now. All right, write your smiley face, and that's it for today. Continue to finish page 41. Finish page 41 on your own. Okay, boys and girls, see you in class.